The next STL container is list. So, generally when we talk about list, it is the meaning of list here is double linked list. Okay, double linked list. So, what all operations we do on double linked list can also be done using list. So, if someone asks you to implement double linked list logic, instead of writing that whole program, defining a temporary variable, pointer, head, inserting at the beginning, end, instead of doing a whole thing, same thing can be implemented easily using the STL list. Okay. So, this list here means double linked list, right. So, we already know about this double linked list, what is its use, how we can do operations front and back, right. At any given location, inserting, deleting elements in the list. Okay. So, lists are sequence containers that allow non-contiguous memory allocations, same like our linked list. Each node in that linked list, double linked list, can be allotted at a different location, need not be continuous. Same is true for this list STL also, right. As compared to the vector, list has slow traversal, but once a position has been found, inserting, deleting are very easy in the double linked list. Okay. So, that is what we said, when we say list in STL, it is double linked list. When you want to implement single linked list, it is forward list. Okay. So, in container class, we are having 5: array, vector, deque, then list. What is the syntax of defining this list? List, the data type, the keyword is list, and the data type, whatever data type you want to give, and the variable list name. Okay, you can give some name to the list L1. See this example here. In this example, I have defined a list of type integer. In this open less than greater than symbol, I gave that. Then I gave the list name as xy list of lower brackets 12, 10, 13, 15, some numbers like this. This is the syntax of declaring and assigning, initializing the list. Okay. It means it is a double linked list with these 4 elements 12, 10, 13 and 15, right. Now, to print that element, if you want to print the list elements, again this is one for loop which we are yet to study in iterators. Okay. That is what, when you have a container with you, when container contains certain elements, right, you have to use iterators to traverse the elements. So, how do you traverse a container? We have to use iterators. So, this is just a syntax here. So, the syntax is very simple. For auto I colon the list name, and simply say C out of I, it will give you the elements in this xy list. So, here answer will be 12, 45, 8 and 6. Okay. We are yet to study about iterators, we will see how to do that, but the prime focus here is about list, that is double linked list. How do you declare it? The syntax is list and then the data type and the variable name xy, some variable name xy, along with that you can give elements like this into the linked list. Now, what all operations can we perform in the linked list? We can insert at the beginning, we can insert at the end at any given location. We can delete at the beginning, delete at the end at any given location, or otherwise double linked list I can traverse forward and I can also traverse backward. Both the ways I can do the traversing. Same things can be done here using some certain functions. So, let us try to see the operations on the list. What are the different operations we are having in the list? So, the first one, front and back. So, front returns the first element in the list, back returns the last element in the list. Okay. Next, push front, push back, same like our double ended queue, deque, right. Push front will insert element at the beginning, push back will insert element at the end. Next, pop front, pop back, deleting the front element, deleting the last element, pop front and pop back. Next, insert, if you want to insert at certain location, if you want to insert at certain position, then we use this insert function onto the list. Okay. So, it will insert new elements in the list before the element at a specified position. Next, size, the number of elements in the list. Begin points it points to the beginning of the list, end points to the end of the list. It is like it is for iterator. We have already seen that v dot begin means it points to the starting location, right. Same way we have here, front gives the value, begin points to that location, begin points to that location. Okay. Front will give the element, the value directly it will be given to you, right. So, these are few operations on double linked list. Okay. Front and back will give the first and last elements, begin and end will give the pointer to the first and last locations. Okay, right. So, the end function returns a iterator pointing to the theoretical last element which follows the last element. Okay, right. So, these things are very common, push front, push back, pop front, pop back, same in double ended queue as well, right. So, this is about double linked list, that is list STL, list container in STL of C++. This is for double linked list. If you want to implement single linked list, we have to go for forward list. Okay. So, let us study what is this forward list, right. So, let us see the syntaxes and the operations of forward list. Okay. So, forward list in STL implements single linked list, that is why elements are always in the forward direction, it can only go in this direction, this is what it is implementing, right. So, using STL makes our programming very very easy, you need not write the whole logic of inserting, handling the pointer. If you want to delete this node, you have to link like this, maintain a temporary pointer, all those headache what we have seen in data structures can be avoided using these containers or STL library, that is why it is very very powerful. So, this one is forward list, that is single linked list. Okay. So, it differs from the list by the fact that forward list keeps track of location of only the next element, while the list tracks both previous and next element, that is what double linked list hand stores location of previous and next element, single linked list stores element of only the next element. Okay. So, the drawback of forward list is that it cannot be iterated backward, that is the drawback of forward list, that is single linked list, right. Forward list is preferred over list when only forward traversal is required, so that we can save the space and time, right. What is the syntax of this? What is syntax of list here? List, data type, the list name and the elements, same is the syntax for forward list, forward underscore list, forward underscore list of then the data type and the list name L1, list name L1, you can give elements like this 10, 20 and 30 here itself, okay, can be assigned like this, right. So, forward list syntax is forward underscore list, type, list name. Okay. Let us see some operations what can be performed on the forward list, what are different types of operations. So, assign is a new function here, we have not seen this before in all those 4 containers, assign, right. It is used to assign values to the forward list. Sorry, I missed it here. List, for list you can assign values like this, no. See the syntax of list, list, the data type integer, the list name L1 for example, and in flower bracket I can give values here itself like this. This is double linked list, I am assigning values directly in the declarations line itself, whereas for forward list you cannot assign it directly, you have to use assign function. So, declaring is simple, declaring is like this, forward underscore list of int and then the list name, you cannot assign here. If you want to assign, you have to use, if you want to assign values, initialize values, you have to use assign function. How to do that? How to assign that? See, if I am having a list L1, I have to write L1 dot assign, L1 dot assign 10, 20, 30, 40 in flower bracket like this. Okay. You have to write L1 dot assign in round bracket, you have to give 10, 20, 30, 40. Okay. That is the first function we have in forward list. See what is assign? This function is used to assign values to the forward list. Its other variant is used to assign repeated elements and using the values of another list. Okay. Next, push front. This function is used to insert elements at the first position in the forward list. The value from this function is copied to the space before the first element. Okay. So, it is like inserting at the beginning, push front, then emplace front. What is this, right? But this no copying operation occurs. Okay. Here what is this is very important, understand the difference between push front and emplace front. Okay. Assume there is a list, I will draw the linked list diagram so that you understand better. Like this, anyhow it is not stored this way, but just explaining you how it is done internally. Push front, right? This is used to insert the element at the first position on forward list. In this location it will insert. The value from this function is copied to the space before first element in the container. Okay. Before first element in the container, whatever I am giving in the push front value, that is copied here. Okay. The size of forward list is increased by 1, whereas emplace front, this function is similar to previous function, but in this no copying operation occurs. The element is created directly at the memory before the first element of the forward list. Okay. So, now let us see. If you use emplace front, a memory block is created and element is inserted. If you use only front, push front, here only the element is stored. Okay. Anyhow, this structure, node structure does not exist in forward in this STL library, just for easy understanding. If you are using emplace front, it will create a memory block. If you use push front, it will just insert the value here and this will be moved forward. Okay. This new memory block will not be created in the push front. Next, pop front, delete the first element. Insert after. Okay. What is this function? Insert after. This function gives us a choice to insert elements at any position in the forward list. Wherever you want to insert an element, that index you give, after that it will insert the elements. Next, emplace after, same thing. No, it will also insert element into the list at any given location. Erase after, delete element after particular position, remove that particular element from the list, remove if based on some condition I can remove that, clear, deletes all the elements from the list. So, these are few functions on the forward list, right. So, if you summarize about this list and forward list, list is double linked list operation where we can insert and delete at both the ends. That is why we have so many functions here, push front, push back, pop front, pop back. Okay. And forward list is single linked list implementation, right. To assign values in single linked list implementation, that is forward list, we have to use assign function, and remaining function remain same, push front, pop front, insert after, erase after, remove, clear, all these things are common functions which we use in the forward list. Okay. So, this is about list and forward list STL containers.